Okay, reminder, the exam 2 will be on Friday, going over everything in chapter 2. What you should be expecting is a problem from 2.1 and 2.2, like finding the derivative of a function using the limit definition. You should expect 3 to 5 problems from sections 2.3, 2.4, and 2.5. Mostly those are the derivative problems. But from section 2.4, I might ask you a limit problem as well. Remember the limits of sine 60 over 60, something like 40, something like that, right? Yeah. From 2.3, 2.4, 2.5. And then section 2.6, one problem with maybe 2 or 3 parts, where I'll give you an equation. I'll be asking you to find the derivative of y with respect to x. I'll be asking you to find the slope of the tangent line at a given point, that I'm going to give you the point, and I might ask you to write down the equation of the tangent line at that point. And then from section 2.8, it's going to be related rate problems, and there will be exactly one problem from related rates. Some of you might be thinking that, well, if there is only one problem from that section, maybe I can get away. I don't care even if I can't do it on the exam. Well, there aren't so many problems on the exam, so that one problem might be worth at least 15 points. So you lose that. If you cannot do that problem, your letter grade goes down by 1 letter grade. Okay? So make sure that you go over all the problems in that section. Yeah.
So you want us to go? I'm sure most everyone knows the English, but you want us to go over and make sure we know like the formula for the volume of the cone and stuff?
Yeah, when you do your homework problems, any formula that you need in your homework problems, you should write it down and memorize them. Okay? All right, so let me go back. Tomorrow I will spend the entire hour on just reviewing for the exam and taking questions, okay? And I'll tell you more about the exam. So now let's go back to section 3.1. I have already posted a new homework on section 3.1. However, it's due only on Sunday, so you don't have to worry about it at this point. But if you have time, you should start doing it. There are 10 problems on that homework, so maybe you should plan on doing at least 5 of them by Saturday and 5 on Sunday maybe. Okay, so let's say I have the graph of a function f like this, and we now understand what we mean by the absolute maximum value of the function on the interval from. So what is the maximum value of this function on the interval from a to b? Well, that's the value f of c. What's the minimum value, absolute minimum value, or the global minimum value of the function on this interval from a to b? Well, that's f of a. What are the local minimum values? The local minimum values occurs at beta 1 and beta 2, right? Beta 1 and beta 2. Local maximum values occurs where? At alpha 1, at c, and at alpha 2, right? Those are the locations of local maximum values, right? Is everybody okay with that? Now, last time I said, well, if you look at the local maximum values and the local minimum values, notice that at those locations, either the slope is 0 or the slope doesn't exist, right? Am I making sense? So the locations where you have the local max or local mean, at those locations, the derivative is either 0 or doesn't exist. Okay? And so we give it a special name. We call these points critical points. So what we want to show after that is that if you have a local max or a local mean at a point, at that point, you must have a critical point. So local max, local mean may only occur at critical points. Okay? So here's our definition for a critical point that we gave last time. A critical point of a function f is a number c in the domain of the function such that the derivative of the function at c is either 0 or the derivative of the function doesn't exist at c, right? So it's a number in the domain where the derivative is either 0 or the derivative doesn't exist. Now, then I sort of discussed in this example how does the graph of a function look like when the derivative is 0 at some point. Is everybody okay with that? So here I am assuming in this example that the function f is continuous around c. So near the point c, the function is continuous. And then I'm saying if the derivative at c is 0, then either derivative is 0 means the tangent line is horizontal at c. So either the graph looks like this, or the graph looks like this, or there is a third possibility. In the first case I have a local mean, second case I have a local max, third case I have neither. So I have that the derivative vanishes at a point, but at that point I have neither a local max nor a local mean. Is that making sense? Pretty soon what I'm going to show you is that if I have a local max or a local mean at a point C, then at that point C must be a critical point. But it doesn't work the other way. If I have a critical point at a number C, that doesn't necessarily mean that I have a local max or a local mean there, precisely because of this possibility, right? If I have a critical point at C, I might not have a local max or a local mean there. However, I'm going to show you later that if I have a local max or a local mean at C, then C must be a critical point. Is everybody okay? So the critical points are the possible locations of local max and local mean. Those are the possible locations of local max and local mean values. So what I want to do next is show you computations of critical points for certain given functions. So let's look at example number 1 on finding critical points. So let's say I have the function f of x, which is 1/3 x squared plus half x. Sorry, I meant to write cube here. 1/3 x cubed plus this, and another mistake, minus 2x. So let's say I have this function, and the question is find the critical. I'm going to write CT to mean critical, okay? PTS for points. Find the critical points of f of x. So remember, what is a critical point? These are the points in the domain of f where the derivative either vanishes or doesn't exist, right? Now, the first thing you want to do is find out what's the domain of f. What's the domain of f? Negative infinity to positive infinity, because it's a what? Polynomial function, right? Okay, now, how would I find the critical points? Well, step number 1. Step number 1 in finding critical points is that you need to find the derivative of the function. So what's the derivative? X squared x minus 2, right? Okay, once you found the derivative, remember, what are the critical points again? These are the points where the derivative either vanishes or doesn't exist. So step number 2 would be solve f prime of x equals to 0. So you want to find values of x where the derivative would be 0 for x in the domain of f, right? So you want to find the Values of x in the domain of f where the derivative is 0. Well, the derivative is 0 means what? We have a formula for the derivative, so let's write that. This is 0. Can you factor that out? Can you factor this out? How would you factor this out? X plus 2, x minus 1. Everybody agrees with that? So x is what? Negative 2 or x is 1. So I found two critical points, right? These are the locations where the derivative vanishes. Step number 3. I'm not done yet because I also need to know where the derivative does not exist. Right? So solve f prime of x does not exist for x in the domain of f. When I say solve this, I mean that find values of x where the derivative doesn't exist. However, what's the derivative? The derivative is x squared plus x minus 2, which is defined, right? It's a polynomial function. We know that a polynomial function is differentiable everywhere, right? So it's defined for all x. For all x. So in this step 3, I get no solution, right? There are no solutions. So my conclusion is, how many critical points do I have? Exactly 2. So the only critical points are x equals to, what was the negative 2 and 1, I think the other one. Is everybody okay with that? Okay. Let's look at a different example. Let's now take the function g of x, and let's say the function g of x looks like the following: 1 plus x squared. Again, the same question. Find the critical points of the function g. Okay, what's the first step? Well, let's say step 0 is the domain. What's the domain? What's the domain? Huh? What did you say? Yeah, all real numbers, because the denominator is 1 plus x squared, and x squared is non-negative, so 1 plus x squared is at least 1, which means that the denominator can never be 0, so this function is defined for any x. Right? Okay, so domain is everything. Now, what is step 1? You find the derivative, right? So what is g prime of x? Well, if I apply the quotient rule, what would I get? 1 plus x squared would be multiplied by what? 0, right? The derivative of 1 is 0. Minus. A lot of people make a mistake right here when they take the derivative of this function. I've seen in previous exams that sometimes people, instead of writing 0, they write 1. And then we will be subtracting the numerator 1 multiplied by the derivative of the denominator, and the derivative of the denominator is 2x. So what we obtain for g prime of x is negative 2x over 1 plus x squared squared. Okay, so we have the derivative. What is step 2? Well, we solve the derivative equals to what? We solve the derivative equals to 0 for x in the domain of g. Well, if the ratio is 0, that means that what is 0? The numerator is 0. That implies that x has to be 0. Once you get this, make sure that when x is 0, the denominator isn't 0 at the same time. So plug in 0 in the denominator, make sure that the denominator is not 0. But is x 0? Well, basically what you're trying to check, is that in the domain of G? Yeah, the domain of G is everything, so 0 is in the domain. What is the step 2? Solve the derivative. Let me just say it this way. Solve G prime of x doesn't exist for x in the domain of G. Well, do I have any solutions here? The derivative is given by this, and this is defined for any x. So no solutions. The derivative is defined for any x. So the answer is the critical points are, well, there is only one. Okay? Everybody is okay with that. Now, I want to do a little bit more difficult question. That is, so far in all the two problems that I did, in both cases, when we tried to find where the derivative doesn't exist, we didn't get any solutions, right? So let's do a problem where that's not going to happen. So here's a function f, which is x to the 2/3 multiplied by 6 minus x to the 1/3. Is everybody okay? Alright, so first of all, what's the domain of f? Anyone? Because we are taking cubic roots, and we can take cube roots of negative numbers as well, right? So this would be defined for any real number. So the domain is still all real numbers. Step 1. Well, what is f prime of x? What do? We apply the product rule, and we apply the product rule by using the two factors, right? Okay, what's the derivative of the first factor? 2/3 x to the negative 1/3, right? Multiplied by the second factor as it is, right? Plus first factor as it is multiplied by the derivative of the second factor. What is that? Anyone? What's the derivative of 6 minus x to the 1/3? 1/3 6 minus x to the negative 2/3, right? It'll be 1/3 minus 1, right? Which would be negative 2/3. Am I missing anything? Derivative of 6 minus x, which would be negative 1. Okay? Alright. Now, the question is, how would you simplify this? Okay? There are a couple of different ways of going about it. Some people will just factor out the negative exponents. Just factor out the negative exponents. Or another way of doing it would be, first of all, write this first term as 2 times 6 minus x to the 1/3 divided by 3 times x to the 1/3. The second term would be negative x to the 2/3 divided by 3 6 minus x to the 2/3. Is that okay? Is everybody okay with that? All right. So how would I simplify this derivative? Like I said, there are a couple of different ways. You can one thing you could do is look at the common denominator and multiply and divide the entire expression by the common denominator, or you can just do it as just add the fractions. What's the common denominator? Anybody? Common denominator, or I should say least common denominator. What's that? 3x to the 1/3 times 6 minus x to the what? 2/3. So that's the common denominator. You agree? I could have taken the common denominator to be 9x to the 1/3. I could have multiplied the two denominator. Okay. So if you are not sure what is the least common denominator, you can just multiply the two denominators. Now, I'm going to be subtracting two terms, right? Okay, what's the first term? In the numerator, I'll be subtracting one term from another. What would be the first? So what are you going to do? You're going to divide the common denominator by the first denominator. If I do that, what do I get? So here what I'm going to get is basically the numerator that I have. I'm going to have the numerator, okay? I'm going to have the numerator, but I'm going to multiply the numerator by something. And then here I'm also going to get the numerator, and it will be multiplied by something. So I'm saying, what am I going to multiply the numerator with? You divide the common denominator by the denominator of the first fraction. What is that? If you divide the common 6 minus x to the 2/3. Very good. And then what would be what do I multiply the second numerator with? X to the 1/3. Everybody agrees. Again, you look at the common denominator here. Then in the numerator, I'm going to subtract. So this would be the first numerator multiplied with something minus the second numerator multiplied with something. So what are this something and something? Well, you divide the common denominator by the first denominator, you get 6 minus x to the 2/3. You divide the common denominator by this denominator here, you're going to get x to the 1/3. Is everybody okay with that? Now you just see that what you have is 2 times what? 6 minus x, right? Minus just x over 3x to the 1/3. 6 minus x to the 2/3. And then what is that? That would be 12 minus 2x minus x. So what is that? 12 minus. So that would be 12 minus 3x. 3x to the 1/3 times 6 minus x to the 1/3. Is everybody okay with that? So that's exactly what the derivative is. So all we did is found that the derivative. Okay, now we are ready for step 2. Solve f prime of x equals to 0 for x in the domain of the function. Well, if the derivative is 0, derivative is a fraction here, right? So if the derivative is 0, then the numerator of the derivative would have to be 0, right? So if the derivative is 0, that would mean what is 0? That would mean that the numerator is 0, and that implies x is what? X is 4. Okay, so now, and is 4 in the domain? Yeah, remember domain is everything. Step 3. solve f prime of x does not exist for x in the domain of f. Well, it doesn't exist for what values of x? Can you just look at the derivative? What are the values of x where it doesn't exist? 0 and 6, because that's going to make the denominator 0, right? Oh, 0. Well, you have a fraction, right? So you cannot divide by 0. So you cannot have 0 in the denominator. So the denominator would be 0 when x is 0 or 6. So in this case, we are getting solutions from step 3, right? In the previous two, we didn't. So what are the critical points? The critical points are x is 0, x is 4, x is 6. Later on in section 3.3 or 3.4, I will be asking you to draw the graph of this function. Okay? We're going to learn how to sketch the graphs of functions, and you'll be graphing sketching the graph of this function. In fact, later. In fact, all of them. One of your exercises would involve finding sketching the graphs of these functions. All right, everybody is clear on how to find critical points. Now, not on this exam, but on the third exam, one question that I usually ask is that I give you a function and I say find the critical points. Okay, and so this is what you have to do for such a problem. Any questions so far? Everybody's okay? All right. So here's what I promised to you. This is called Fermat's theorem, and what it says is the following. It says that if f has a local max or a min at some number c, and f prime of c exists, then the derivative at c must be 0. Am I making sense? So this theorem says that what I promised you. Remember I said if you have a local max or a local mean at a point, at that point you must have a critical point. So that's what we are saying here. So another way of interpreting this result is that if you have a local max or a local mean at a point, at that point you must have a critical point. Is that making sense? Remember, local max or local mean means locally that's the maximum value of the function, right? If I have that f of c is a local max, it means that locally f of c is the largest value of f. That is, in an interval surrounding c, f of c is the largest value, right? Okay, so one implication of this Fermat's theorem is that local max and min may only occur at critical points. Okay, that's the implication of this result. Okay. So if you have to find the local maximum and local minimum values of a function, what's the first thing you would want to do? Well, what are the possible locations of local maximum? Critical points. You find the critical points, and then you have to decide whether at each of those critical points you have a local max or a local mean or neither. Okay? Is that making sense? Is everybody okay with that? So if I want to find all the local max and local mean values of a function, the first thing I do is find the critical points, and those are the only possible locations of the local max and local mean. And once I find the critical points, I have to determine whether at each point I have a local or local max or a local min, or maybe neither. Okay, and we're going to see that later. Is everybody okay with this? Okay. And here is the another theorem, which is called the extreme value theorem. And so this one says the following: if f is continuous on a closed bounded interval from a to b, then f attains an absolute maximum and an absolute minimum on AB. So if f is continuous on an interval from a to b, I know that f has to attain a absolute maximum. It has to attain an absolute minimum. Remember, I gave you an example before where we have a function like this one, right? This is a function defined from a to b, right? It's defined everywhere between a and b. However, it is not continuous, right? And notice that it doesn't have an absolute maximum. Remember this example? It doesn't have an absolute maximum. This function can be made as close to 4 as I desire, right? I can make it as close to 4 as I want to. However, the function does not take on the value 4, so I cannot say 4 is the absolute maximum value of the function. Okay? But if you have a continuous function, then I know this extreme value theorem is guaranteeing that there is an absolute maximum value of the function on that interval. There is an absolute minimum value of the function on that interval as well. Is that making sense? Is everybody okay? The next problem is then, if I give you a function which is continuous over an interval from, let's say, 1 to 2, how would you find the absolute maximum value, and how would you find the absolute minimum value of that function? Okay, so let's do an example like that. Is everybody clear on what is expressed by the theorem? So the question is, find the absolute maximum and absolute minimum of the function f of x, which is 3x squared minus 6x. Oops, sorry. That's actually the derivative. X cubed minus 3x squared plus 1 on the interval from -½ up to 4. What in the extreme value theorem? Remember the interval is a finite interval, right? If you have a function defined on -∞ to +∞, for example, or on an open interval, there may not be an absolute maximum or an absolute minimum. Am I making sense? For example, if you look at this function, if I ask you what is the absolute maximum value of this function over -∞ to +∞, what would you say? What would be the absolute maximum of this function when you take x to be anything between -∞ to +∞? Well, it doesn't exist because I can make the value of this function as big as I want to by taking x big enough, right? So this function would not have an absolute maximum on the entire real line. But on a finite interval, the extreme value theorem says there is one. And the question is, how do I find it? Well, what we know is that if I have a finite interval, what are the possible locations of the absolute maximum and absolute minimum? If you think about the possible locations, the possible locations are the local max, local mean, or the end points of the graph, right, over the interval. So the absolute max may occur only at those points. So my job will be to find those points. Well, so the first step in this to do such a problem is that you are going to find the derivative. You're going to find the critical points. Okay, so first step is find critical points. Well, how do I find the critical points? Well, I take the derivative, and the derivative is 3x squared minus 6x, and then I am going to solve the derivative equals to 0, and I'm going to solve I also need to solve the derivative doesn't exist for x in the domain of x, for x where? For x inside of the given domain, right? What's the given domain? -½ to 4. Notice that I'm using open interval here because I am going to consider -½ and 4 as endpoints anyway, so I don't have to worry about including them here. So the derivative would be 0, means that 3x squared minus 6x is 0. If I factor out 3x, I get x minus 2, right? So what is x? 0 or 2, right? So I got, and are those values inside of both of them? Both of them are inside of that interval? Yeah. So both of them are critical points there. Do I get any solutions from here? None, right? The derivative exists everywhere. So I found only 2 critical points. So I know that the absolute maximum value would occur at the critical points or at the end points of the interval. So it will be -½ and 4. What I have to do is find out the values of f at these points. So what's the value of the function when x is 0? Look at the formula for f. You're going to get the value 1. When at 2, what's the value? -3. At -½ the value would be 1/8. And at 4 the value would be 17, in fact. So I know that absolute max, absolute mean exist. Both of them exist. And I also know that they can only occur at the critical points or at the end points. While all I have to do from these 4 values, pick out the largest one. That's the absolute maximum. And what's the absolute minimum? That's the absolute minimum. Is everybody okay? I'm done with 3.1, except that I planned on giving you a justification for the first theorem that I gave. However, bad luck, we didn't have time.